Welcome to Summarize Science, where we break down complex research into simple terms. Today, we're looking at a paper that uses advanced AI to tackle a growing problem in our cities: extreme heat. As cities grow, all the concrete, buildings, and lack of vegetation trap heat, making them much warmer than surrounding rural areas. This is the urban heat island effect, and it can make cities dangerously hot, increasing energy use and health risks. To fight this, city planners need detailed temperature maps to know where to focus their efforts, but getting that data is often difficult and expensive. Researchers in this paper propose a solution using a powerful type of AI called a Geospatial Foundation Model, or GFM. Think of it as a super smart map reader that has been trained on immense amounts of global satellite and climate data. To see if the AI was accurate, they first established a ground truth. They measured the real cooling effect of existing city parks, looking at how temperature changes inside the park and how that coolness spills over into nearby streets. They found that parks have strong internal cooling, and this effect can lower temperatures in the surrounding neighborhood by up to 3.5 degrees Celsius. When they compared the real-world data to the AI's predictions, the model was able to replicate these complex cooling patterns with very high accuracy. Next, they tested if the AI could predict future heat waves. They took a city the AI had never seen before, trained it on only the cooler 90% of temperature data, and then asked it to predict the hottest 10% of days. The model performed incredibly well, proving it can forecast extreme heat events beyond its direct training. Using this capability, they projected how much hotter that city's urban heat island would get by 2050 and 2100 under different climate change scenarios. Finally, they did something really cool: a digital simulation. In a map of Prague, they digitally painted in a new park where there wasn't one before. The AI then predicted the thermal impact, showing exactly how much this hypothetical park would cool the surrounding neighborhood. So, what's the big takeaway from all of this? This research presents a complete workflow that transforms this AI from just a measurement tool into an interactive simulator for urban planning. City planners can now test the potential impact of green spaces, like new parks or green roofs, before a single shovel ever hits the ground. They can virtually experiment to see which interventions will be most effective at cooling our neighborhoods and protecting residents. This allows for smarter, evidence-based decisions to build more comfortable and climate-resilient cities for the future. It's a powerful example of how AI can help us design better solutions to adapt to a changing climate. That's all for this episode of Summarize Science. Thanks for watching.